All right, so overall, pretty good job. The only thing was with opposite rays, tended to be a little bit confusing. Remind me what non-collinear means? Not on the same line. So you have to have, if you want two non-collinear points, that means one of them has to be what? One of them would have to be what? Yeah, so pick a point that's not on a line here with something else. Like if I pick C, what's the only point that's not on the line with C? D, so you would put C and D. What about E?
It's still on the line.
It's on the line with C, so you couldn't pick it because it would be collinear with C. Good. Is B collinear with C? Yes. Is B collinear with D? Yes. Is it on the same line as C? No, but it's still collinear with those because they are connected. Okay, so collinear doesn't mean it has to be on one line. It just means there is a line that connects them. All right, which one is a line and which one is a segment? How can you tell them apart? How can you tell apart a segment and a line? Micah?
The segment doesn't keep going.
Okay, how do you tell that? Geometrically, what do we put on that line then? Yeah, endpoints, right? So it has endpoints, so they look like points, as opposed to the line, which has what on the ends? Arrows, exactly, which means they go on forever. Good. Okay, so today what we're going to talk about is we're going to talk about distance of a line and how you measure distance of a line. So if I just slapped this up on the board and I said, tell me the distance of this line segment, what would you have to do to figure that out? What else would you need from me? What more information might you need? Or tools, or what else would you need? You might need a ruler. Okay, that would be one way to do it. Good. Maybe even a yardstick because it's kind of long, right? Okay, measuring tape, some type of measuring tool, right? Because I haven't given you any other information. All I've told you is, here's this line segment, find the distance of it. What if I gave you this? That's more helpful because what does that do for you? It shows you the measure of it. It's basically like this is acting like your ruler, right? This is a number line that's acting like your ruler. The difference is when you measure something with a ruler, where do you start it? At the very beginning, right? Right at the 0. What's the difference between this number line right here and where you would start a ruler? Yeah, it starts at 3. So how would you figure out how long that is then? Yeah, subtract what, Danny? Why? Exactly. That's the difference between how far it goes to the right and how far it goes to the left. Perfect. So we're doing 3 minus 7 or 7 minus 3? 7 minus 3. Very good. So we take the one on the right and subtract the one on the left. So 7 minus 3, which means how long is that line? 4. And we would say in this case, 4 units, because I don't know if that's centimeters, feet, inches, yards, whatever. I don't have a unit, so you can just leave it as 4 or you can put 4 units. Is there another way you could do it? Is there maybe like a less mathematical way you could do it? Count them, exactly. So I can go, this is 1, 2, 3, 4. That's how far it is, okay? Both of those things will work, counting or subtracting. Does it matter if you subtract the other way?
Yes.
Yes? Why?
Because then it will be 7 with negative.
Uh-huh.
And then you'll get a negative.
So you'd end up with a negative answer of -4. Can distance be negative?
No.
No? So if you do it backwards, if you forget and you do it backwards, if you get a -4, what should you do to correct yourself? Just change it, so the absolute value. If we were saying it in a mathematical way, we would say do the absolute value of that number. What's the absolute value of -4? 4. +4. Okay, because distance always has to be what? Positive. It always has to be positive. If I walk 10 feet this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I turn around and go that way, am I going -10 feet? No, what am I doing? I'm going 10 feet, just in a different direction, right? So we're still talking about positive distance. Okay, how long is AB? 10, how'd you get that? 15 minus 5 equals 10, so it's 10 units. All right, how long is BC? How long is BC? 10. What would be the subtraction I would do here?
25
So that one is also 10 units. So then if I said how long is AC, how long is AC?
20.
AC is 20. What could you do to get that? You could either say 25 minus 5 and get 20. Or you know that this one's 10 and this one's 10. So how long is the whole thing? 20. And what are you doing to get that? Adding. Okay, so you're adding together the pieces to get the whole. That's called the segment addition postulate, which is a fancy way of just saying if I add together this piece and this piece, I get the whole thing. So in this figure right here, if I add together AB, I'll tell you, let's say it's 3, and I add together BC, and let's say it's 7, then how long is AC?
10.
Yep. So segment addition postulate just means if you add together the parts, it gives you the whole. So when you do these, you'll see problems like this, like number 1 right here, where it says B is between A and C. My biggest piece of advice in geometry is whenever you see a word problem that doesn't have a picture, my first piece of advice is draw yourself a picture. If you can visualize it, you will get it right way more than you will get it wrong, okay? So we already actually have a picture of this. B is between A and C, because that's what's happening right here, but I'm gonna draw it again. So B is in between A and C. AB is 12. So that means I'm going to label this one 12. And BC is 14. So what would I do to figure out how long AC is? Just add them together. Good. What's 12 plus 14? 26. So 26 centimeters. Same thing in number 2. My first advice, draw a picture of it. Even if you just drew one, that took no time at all, so I'm going to draw another one. B is between A and C. Here it tells me AB is 12. But now what else does it tell me?
AC is 32.
AC is 32. So what's the difference?
That it doesn't give you the unit for B and C.
It doesn't give you the unit for BC? Yeah, it doesn't give you the measure for BC. What does it give you?
The entire one.
It gives you the entire thing. So the entire thing, AC, is 32. So then what would you have to do here that would be different? Subtract. Why? Because you're looking for the other part, right? It gave you a part and a total, so now we have to subtract. So I'm going to do 32 minus 12, which is what? 20. Good. So BC must be 20 centimeters. What if I give you a picture, but it's got labels like this? What's the difference with these labels? There's like expressions in there, right? There's algebraic expressions in there, but it doesn't change the process, right? What do you do with the parts to get the whole? Like if this were 5 and 6, what would you do with those two things? Add them. So these are algebraic expressions. What are you going to do with them? Add them, and they're going to equal what? 4x. Okay, so we're just going to have an algebraic expression here, which is 2x plus 7 plus 28 equals 4x. Let's back up for a second. How did we know that we could add these two to get this one? Because you can add up the parts to give you the whole. And what are the parts here? 2x plus 7 and 28. And what's our whole? 4x. So something that happens all the time is you guys could do 20 of these with numbers in them, and then I slap the letter x in, and all of a sudden people are like, I have no idea how to do this. You do know how to do it. Just think about what you'd do if they were just numbers and do the same thing, okay? And then it's just algebra. So now this goes back to algebra 1. So what do we do in this equation? Combine our like terms. What are our like terms? 7 and 28, which would be what? 35, good. 2x plus 35 equals 4x. Now what do I have to do? I have to collect my x's, right? I have to get all my x's on one side. So which one should I move, the 2x or the 4x? 2x. Why the 2x? You could move either, but why does it make more sense to move the 2x? 4x is bigger and it'll keep it positive, right? So how do I move a positive 2x? What do I have left here? Good. And how would I finish? Good. X equals 17.5. You guys will always be able to use calculators in this class, so if I do that part quickly, it's just because I know in reality you would use a calculator, okay? So 17.5 equals X. Now, go back to the question. What does the question ask you to find? RT. So is it asking me to find X? So what do I have to do now? Last thing. I have to plug it in, but to which one?
To X.
To this one? That would give me RS.
Oh, no,
To 4x because I want to find RT, which is the whole thing. So I'm going to do 4, and then there's no sign, so what kind of math am I doing? Multiplication. So I'm doing 17.5 times 4, which is going to give me 70. So this right here is why we do geometry after Algebra 1. Because if you did geometry before you did Algebra 1, you would probably have not seen this expression before, but you guys are able to manipulate expressions because you've already done Algebra 1, okay? So whenever you see stuff like this, just think back to how you learned it last year. What's the biggest mistake you think people make here? If you had to guess, what do you think the biggest mistake students make here is? They don't plug it in. Yep, they stop right here, okay? Is that like the end of the world? No, you've done the hard stuff and you've shown me the understanding, but just always be careful and go back and look at what they're asking for. Because sometimes it'll just say find X and then you'd be done. But if it says find RT, just make sure you plug it in. If it's like a 5-point problem, you're going to lose a point if you don't plug it in. Again, not the end of the world, but just careful reading, okay? And you have a calculator, so there's no reason it should be that big a challenge. Okay, questions on segment addition postulate? Fancy way of saying what? Part plus part equals whole. Is that something you didn't know before you walked in this room? No, you knew it. It's just putting a different name to it. Okay? All right. Go to your boards and try it. Remember, whenever you are looking for a distance, what kind of math do you do with the two numbers? Adding or subtracting. You're probably going to subtract most of the time when you're looking for the distance. Okay, go. There are 6. Okay, so let's talk about some important terms. You'll notice on your slides, maybe you won't notice, but I noticed I spelled midpoint wrong. On your slides it says midpont. That's not a thing. So I missed the I in there. So if you want to correct it, you can. It's midpoint. There should be 2 I's, not midpont. Okay, what is a midpoint? What is a midpoint? The point right in the middle. So the point directly in the middle. And in the problem that you guys did about J, K, L, if KL was 4 and it says K is the midpoint, what does that tell you about JK? JK is also 4, okay? Because since K is the midpoint, that means it's in the middle. So if one side is 4, the other side is 4. You could also use that to find the whole thing. How long is JL? 8, good, because if each half is 4, then together it's 8. All right, what do you think bisect means? Cut it in half, exactly. Cut it into 2 pieces. Okay. So you could say I bisect my sandwich when I cut it in half. All right, nobody does, but you could if you wanted to. So then a segment bisector is just a point that cuts a segment in half. Up here, K is a segment bisector because it cuts JL in half. So K is a segment bisector as well as a midpoint. All right, it's kind of the two names for the same thing. What are congruent segments? They're what? Even segments, equal segments. Congruent just means identical, okay? So what are two congruent segments in this figure right here? JK is congruent to KL, very good. So two or more equal segments. The symbol for congruent, we'll start using the symbol for it, is an equal sign with a tilde on top or just a wiggle on top. That means congruent. So if you see that, what that means is those two things are equal. So here we would say that JK is congruent to KL. All right, so how can we use a midpoint then to find the lengths? If I tell you B is a midpoint of AC, then what do you know about AB and BC? They're the same length. So what algebraic equation could I set up then? 3x plus 4 equals 5x. Guillermo, why? Am I adding them together? No? I'm making them equal, and I know that they're equal because I told you B is a midpoint. If I don't tell you B is a midpoint, can you say this? No, I have to tell you that. If I don't say it, you can't do it. You would just say, I can't do this problem because I don't have enough information. Now that I know this, though, what can I do? Yeah, subtract 3x from here and 3x from here. And you end up with 4 equals, so then x must equal. All right, and the question says find the lengths. So then am I done here or do I need to plug back in? Plug it back in. So if x is 2, what's this? 10. And if I know this is 10, what's this have to be? 10. Good, so that works if I tell you B is a midpoint. That works if I tell you B is a midpoint, you can say that those two things are equal because it makes congruent segments. It's a segment bisector. All right, so what would be my algebraic equation here if B is a midpoint?
2x plus 8 equals 6x.
Good, do that part at your seats. 2x plus 8 equals 6x. Does anyone have an x value? Either? X equals 2. Who else? Does other people get 2? All right, so x equals 2. So then if x equals 2, what's BC? So then that means that's also 12. Why do I pick BC? Like, why did I plug into BC? It's easier. Could you have plugged it into the other one? Yeah, there's just, it's not even harder really, right? Because 2 times 2 is 4 plus 8. You'd still get 12. It's just this one looks shorter to me, so I'm going to do that one because I know that they're going to be the same, right? Once I figure out one, I know the other. If I asked you for AC then, what's AC? 24. Very good. Okay, so before you get up, you guys are going to do these 4 problems. You're going to do these 4 problems. Make sure you draw a picture for number 14. All right, it'll be much easier if you do that. If you want to grab a calculator, you can. There's fractions in this one. You can also keep in mind you can count on the number line if you don't want to subtract. Okay? All right, go.